Hey everyone, welcome back. Video lecture 16. After today, we have 6 video lectures left. That's it. Semester will be over. So yeah, just make sure that you're plugged in, asking all the questions, getting the help when you need it, okay? Remember, we've got office hours for your instructor. We've got a learning center that can help you out. Just make sure you're taking advantage of stuff, okay? So today we're going to talk about factor by grouping. Um, Final topic for module 5A. First, I want to talk about what it is and when it's useful. So, you're going to see things that look like this expression up above here. What we're going to be looking for specifically in this class, this isn't always the case, but specifically in this class, what we're looking for is we're going to continue to use our greatest common factor. We're going to use it a little bit differently. We're going to use kind of greatest common factor while looking at groups of terms. So we're not going to be looking at all the terms at once, but really we're going to be focusing on a group of terms at a time. So it's useful when you're able to group things, and to group things, you're probably going to have like an even number of terms. So in our case, we're going to largely be looking at things with 4 terms. And we're going to be just kind of grouping them together, see if we can see any similarities within groups. All right. So I didn't write anything down, but make sure you take a moment to yourself, get something down there. What is factor by grouping and when is it useful? Okay. All right. So our example problems for today. So again, we're going to look at things in this class. Largely, we've got 4 terms for our polynomial. And if we look across all 4 terms, so previously, right, we talked about greatest common factor. We always want to check for that, okay, right? If we have greatest common factor, we have that ability to simplify our expression a little bit. So if we look across all the terms, right, 4, 5, 20, 25, is there any number that divides all 4 of those? And the answer is just 1. 1's the only number that divides all of those. So that doesn't help us out. And then we look at the variables. Do they all have a y? No, so we can't divide out a y. So looking across all 4 terms, greatest common factor doesn't help us. But with our strategy today, we're going to talk about looking at groups specifically. So what we're going to do is we're going to look at the first 2 terms, right? A group of 2. And then we're going to look at the last 2 terms, another group of 2. And we're going to ask ourselves, well, there's not a GCF across all 4 terms, but let's look at our groups specifically. So if we look at the first 2, right, we got a 4 and a 5. Anything divide both 4 and 5? Just 1. So nothing there. But then we look at our variables. We got y to the 3rd and we've got y squared. What do those have in common? What's the greatest number of y's that they have in common? They both have y squared, at least y squared. So let's factor out a y squared from the first 2 terms, right? We're focused on the first group. So if we factor out y squared from 4y cubed, right, the 4 is still going to be there. And if I take out y squared from y cubed, I would have a y left over. Okay, next term is a negative 5y squared. I didn't do anything to the negative 5. And if I took out y squared, there's no more y's inside the parentheses there, okay? Again, you can kind of check yourself, make sure that you did this factoring correctly. You should end up with what you started with if you multiply it out. Okay, let's do the second portion. So we got our second group of 20y and negative 25. What goes into 20 and 25? Largest thing, 5. So we're going to write down a plus 5 since this is a positive right here. Do they both have a y that we could take out? No. So we are going to divide both of these pieces by a 5. So dividing by 5, we would have 4y, and dividing by 5, we would have a minus 5. Okay, what do we notice about what we have here? This is how we left off in video lecture 15, right? The final problem in video lecture 15 presented us with this, right? If we look across our, different color, if we look across our 2, portions here, what do those 2 portions have in common? They both have this 4y minus 5. So these 2 pieces, right, have a 4y minus 5 in common. So we can factor out a 4y minus 5. And if we factor out a 4y minus 5, the 2 things that are left over is y squared plus 5. And that is completely factored, right? This is written as something that we would normally multiply out, right? We would double distribute, we would FOIL. Foiling, right? When we double distribute, we end up with four terms, and sometimes they combine. But if they don't combine, right, we've got four terms, and that's what we started with. Okay, so that's the main thing that we're doing here. We're trying to ask ourselves, what did I multiply to get to this thing that I've been given? Okay, so everything that we write when we factor should look like a multiplication problem. All right, cool. Let's do this a couple more times. So looking at, right, we got four terms. If we look across all four terms, nothing in common. Look at the first two and then the second two set. If you feel confident about that first one, pause the video, try this one out, okay? So we're looking at 8 and 10. What goes in 8 and 10? 2. X to the third and x squared, we can take an x squared out. And then let's go ahead and write our leftovers inside parentheses. So if we divide by 2, we're left with 4. And if we divide by x squared, we're left with an x. Dividing by 2, we're left with a 5. No more x squared because it's out front. Okay, do it again. We've got a negative 20 and a negative 25. Okay, similar to a tip that I gave last time is if your leading expression is negative, or your leading coefficient, if your leading coefficient here is a negative, you need to factor out a negative. So what's the largest, what's the number that we can divide 20 and 25 by? It's 5. We are going to divide by a negative 5. Okay, x will not go into both of these terms, so we're just going to write a negative 5. So now if we divide by negative 5, that's a 4, and dividing negative 25 by negative 5, that gives us a positive 5. Okay, main thing here, right, you have to make sure that these binomials match up perfectly. They can't be off by a sign. They have to match up perfectly. If you didn't make that 5 a negative and you just left it a positive, you would end up having some extra negatives inside your parentheses here. So you just have to make sure that, you know, if that does happen, go back and revisit it. That's what you need to do differently, okay? All right, so now final step, right? Looking across, we have a 4x plus 5 in common. We can factor out a 4x plus 5. We would be left with 2x squared minus 5. Final answer looks like a double distribution, a binomial times a binomial. All right, two more. All right, so we got four terms. Let's look at our first two and then our next two. So in our first two, we got 12v and 6w, 12 and 6. We can divide by 6. And v and w cannot divide. They're different variables. They don't have that commonality. So dividing by 6, we would be left with 2v and a w. We look at the next two. We got a VW and a 2V squared. What do those two things have in common? What do those two terms have in common? This one and this one. They have a V in common. So we're going to write plus V, and we're going to divide by a V. If we divide by V in the first term, a W is left over. And if we divide by V in the second term, we have 2V. All right. So now we look at what we've got. Are the binomials exactly the same? They're not, right? We got 2v minus w, and then we got w minus 2v. What we can do to see what's going on, right? This is the 2v is first in the first binomial, but the 2v is second in the second binomial. Let's rewrite that second one just to kind of diagnose what we need to do here. So if I flip this second one, that would be negative 2v, and that w is positive, so we're going to write plus w. Okay, so now looking, right? In the first one, in the first binomial, 2v is positive. In the second one, then 2v is negative. In the first one, the w is negative. In the second one, the w is positive. They are off, right? They're off by a sign. So what could we do to fix this? We have to have these matching perfectly. Otherwise, we can't do the next step. Instead of, right, like if we divided one of these by -1, if we divided one of them by -1, the signs would change and we would have something that matches up. So what I'm going to propose that we do, and you could do either one, I'm going to, instead of dividing by a positive v here, I'm going to divide by a negative v. If I pull out a negative, right, if I undistribute a negative from these two terms, I would have, so I'm not changing this first one. I want to factor out a negative 1. So if I divide this by a negative, right, a negative divided by negative leaves me a positive 2v, and then I divide by negative with the w, I get minus w. Okay, so now we have them matching. So in this one, right, we had a problem solve a little bit. We did our first step. They're not matching up perfectly. So what you need to do is write them in the same order, okay, and then diagnose the issue. If the issue is a negative sign, let's factor out a negative, okay? So now, last step, right? We've got 2v minus w and 2v minus w. That's great. That's going to be what we're able to take out front. And then our leftovers is a 6 minus a v. Final answer. Okay. So take note of what happened there and how you might, diagnose if this happens to you. Okay. All right, one more. So we got 4a minus ab and then 4 minus b. So let's look at the first terms. The first ones, right? We got 4a and ab. What would go into 4a and ab? Just a single a. So if we divide both of these by a, we'd have 4 minus b. And then if we look at the next pieces, we've got a 4 minus a b. What goes into 4 and b? The best thing that would go into that is a 1, right? You need to make sure you record this. A 1. If you divide by 1, nothing changes. And maybe you noticed this earlier, right? Like we already had a 4 minus a b. And that's what we had here. That's what we wanted. So we didn't want to change it at all. We just needed to, we need to write this 1 so we know what to write in our other binomial here in this next step. Okay. So final step, we've got our 4 minus b matching. So we've got 4 minus b factored out. Our leftovers would be an a plus a 1. Final answer, binomial times a binomial that would get double distributed, FOILed, we'd have 4 terms. Okay. All right, try one for class. This is the one I would love for you to try. Make sure that you come to class with this attempted. Okay. Great job again today. Keep moving, doing a great job. We're going to be at the end before you know it. All right, take care.